Okay, so we just finished up on chapter 1 last week on voting theory and how different ways that we calculate votes could determine the winner, and you could get different results depending on which way you went through and counted it. And so I came up and I found this video yesterday trying to search some information for you guys for our next chapter, and saw this and just thought it was a great kind of review of everything that we just covered. And it's a TED Talk. If you're not familiar with those or are educational, I'm not going to record me playing the video, but if you come and watch because you weren't able to make it to lecture today, I'll have this posted under week 3 a little bit later after class to the link so that you can watch it. So we're going to look at one more video that is now going to kind of describe what we're going to get into. So we were looking at the different voting methods on how to count votes and the different ways we could come up with a result. This next chapter that we're going to be starting to look at is different people when you're voting may not have the same weight as everybody else. So you might be talking about a company, you might be talking about drafts for a sports team, but the voting members don't all have the same weighting. And you might even think of this as, you know, the United States and how we vote with electoral votes and how some states have more weight than other states. And so let's watch this other video, and then I'm also going to post this on the Canvas page, so those of you who didn't make class can see it. I'm going to mute everybody. Let me know if you have any problems with this coming through okay. Stop the video real quick. Okay, so in this chapter again, we're going to be looking at weighted voting, where not everybody's vote counts the same or is equal to one another. And so that last video, the YouTube video, talked more about electoral votes and was kind of a great example of how the United States works and their voting system for the president. So that is also kind of cool because we're in a presidential voting year. So and maybe we can have some discussions a little bit later on if we think electoral votes should be the way we do it, or if we should go doing popular vote. Okay, so this first section, 2.1, talks a lot about, just has a lot of definitions and terminology that we'll be using throughout this chapter. I'm looking for my pen. So first of all, when we're looking at voting, we're going to talk about players. Let me just change this. Okay, so players are the people voting. The quota, this is the number of votes. Of votes needed for a motion or a person to win, whatever you're talking about. So for a motion to pass. Weights. So we talk about weights as being how much weight does that person have while they're voting. So the voting power of a player. Okay, so when we're setting this up and we're looking at a ballot, this is how we can read it. And so reading ballots, you're going to have this Q here, and I think maybe they use little q, but it doesn't really matter. So this is what the quota is. And then they're going to have some numbers in here. So W1, W2, W3, dot, 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 to WN. So in this case, this first number, this is the quota. And this W1, this is the weight of one of the players. And we're going to call them player 1. And you're going to denote player 1 with a capital P and a little 1 subscript. So W2, this is the weight of the player 2. And WN, this is the weight of player N. So a piece of N. So let's denote V, capital V, equals the total number of votes possible. So to get the number of votes possible, basically if you add the weight of each player, that would be the number of votes possible in that voting system. And so V in this case is equal to the weight of player 1 plus the weight of player 2 plus the weight of players 3 all the way to the nth person voting. So usually when you're listing the weight of each player, you're going to list them from the biggest amount of weight to the smallest amount of weight. So we're going to list these from largest to lowest. List the weights. From highest to lowest. So a couple of things I noticed when I was going through preparing for the lecture was a few things that you guys need to remember. And if you don't remember these things, I'll quickly kind of go through it while we're talking about it, but then you might need to go back and look this up. But you need to know how to find a percent of a number. So if they want 75% of the vote, you need to know how to find 75% of the voting weight V. So just really quick, to find a percent, you need to change it to decimal form. That's where you divide by 100, or move the decimal place over 2 places to the left. Actually, 20%. Yeah. So 20% would be 0.20 or 0.2. 75% would be 0.75, and you would multiply that value times the number, and that would give you what the percent of that number is. Another thing you guys need to be able to do is to rewrite a fraction. So if they wanted as a number, so, or a fraction of a number. So if they said the person needs 2/3 of the vote, or the motion needs 2/3 of the vote to pass, and then you need to know that when you're taking a fraction of a number, you're multiplying. You need to know how to multiply fractions. You need to know how to reduce fractions. Let me see. Okay, so those were the couple of things I was thinking, okay, these are things my students need to know or recall while going through at least these first couple sections. So let's pull out an example, and then we're going to go through some more terminology as we go through these examples. So I'm going to read what I have in front of me. I'm not going to write everything, but I'll read it, and then we'll come back and we'll pull out the important information and write it down. And so if you're curious and you want to go back and look at what problem, you would be going back to page 60 in chapter 2. I'm on 2.1, and I'm just going to start with number 1. Okay, so it says 5 partners, piece of 1, piece of 2, piece of 3, and piece of 5 jointly own the Gaussian Electric Company. Piece of 1 owns 15 shares of the company. Piece of 2 owns 12 shares. Piece of 3 and piece of 4 each own 10 shares, and piece of 5 owns 3 shares. With the usual agreement that 1 share equals 1 vote, describe the partnership as a weighted voting system using the standard notation, where we were just showing you that bracket Q colon W sub 1 ... to W sub n, if A, the decision and the partnership are made by simple majority. Okay, so we're given information, and we're given information that we have multiple players. Just zoom this in. And we have the following. We have the players, and we have their weights. Okay, so piece of 1, their weight, going back here, was 15 shares. Piece of 2, their weight in the company, they own 12 shares. Piece of 3 and piece of 4 each own 10 shares. So piece of 3 has 10, so weight is 10. Piece of 4, their weight is 10. Where piece of 5 owns 3 shares, is 3. Part A, describe the standard notation if the decisions in the partnership are made by a simple majority. Okay, so decisions are made by a simple majority. Okay, so we need to figure out what the majority is. So we need to figure out how many total weights there are, total weight of a voting system of all the people that can play. So total number of votes possible. So we're going to look at adding the weight of each player. So 15 plus 12 plus 10 plus 10 plus 3. So 15 plus 12, that's 27, plus 10 is 37, plus 10 is 47, plus 3. So 50 votes possible. Okay, so to get the majority, simple majority, that means they need over 50%. So to have a simple majority, they need over, not 50%, but over 50%. for the decision to pass. Okay, so we know that half of the votes, if there's 50 people, 50% is 25, but they need more than 25. It's impossible to have half of a person vote. So they're going to need 26 or half of a vote. So they're going to need 26 votes. So 50% times V. This has to be greater than, or has to, the votes need to be greater than this. So we said that 25, the number of votes have to be greater than 25. So 26 votes is the quota. If it wants a simple majority. And so to write this out, we're going to put the quota, so we're going to have brackets. We mark the quota, which we found to be 26 people, colon, and then we're going to mark down the weights of each candidate or each voting player, and largest to smallest, which they list. So 15, 12, 10, 10, and 3. Okay, so part B, decisions in the partnership requires 2/3 of the vote. So rewriting the standard notation of the voting system. So write the standard notation of the voting system. If 2/3 of the votes are needed to pass a decision. So it's almost the same, right, how we would write it above. We just need to change the quota. We need to figure out what 2/3 of our 50 votes are. Decision. I don't think I spelled it right. Okay, so 2/3 of 26. I'm sorry, not 26, 50. Okay, so notice this isn't going to simplify. You can think of 50 as 50 over 1. 3 doesn't go into 50, don't have any common factors. Multiplying fractions, you multiply straight across. So you have 2 times 50 is 100, all over 3 times 1, which is 3. So this is, that doesn't make much sense to me. So let's rewrite this as a mixed number. So you should be able to go from improper fractions to mixed numbers. 3 goes into 10 3 times. That's 9, leaving me with a remainder of 1, and 3 goes into 10 again 3 times. So this is 33 and 1/3. Okay, so again, it doesn't make sense to have a 1/3 of a vote. So in order for a decision to be passed, they're going to need a quota of 34 votes. Okay, so again, writing the standard voting system. In this case, quota is 34, but the weights of the voters are still the same. So going down in the order, player 1 has 15, player 2 has 12, player 3 has 10, player 4 has 10, and player 3, I'm sorry, not 3, player 5 has weight 3. Okay, so just terminology and how we would rewrite the standard notation of the voting system, and how, looking at it, you can go back and read it. So if you see this, you should know what the quota is. You should know how many players, because you can count 1, 2, 3, 4, 5 players in here, and what the weight of each player is.
Can you move the screen up a little bit? I can't see the very bottom.
Yeah.
Yes, thank you.
While you guys are writing that, let me grab another one. Okay, so there's a couple of other things that you have to be aware of. We say a player is a dummy player if their vote doesn't matter. There's no way that their vote is going to matter to make a motion to pass or decision to pass. We say that there's a dictatorship, or one of the players is a dictator if they have all the power. So basically, nothing's going to pass unless this person votes. And so let me write that down. So we say a player is considered a dummy. Not very nice, is it? If the player weight in the voting system doesn't matter. And they can never use their vote to pass a motion. So maybe let's go up to that first piece that we had looked at earlier, where we had, it was a simple majority. And let's see if any of these players are a dummy player in this simple majority. Let me see. So are any of these players considered a dummy? Okay, so let's go to the person who has the least amount of weight, which is player 3. And so what we call coalitions are all the different possible ways that people can vote. So for instance, we could just have, let's do a coalition. Again, this is ways a voter can vote, or the different ways people can vote. Different voting possibilities. Okay, so let's just say we have player 1. This could be a coalition. Usually you do this with set notation. player one. Their weight, if it was just player one that voted for something to pass, then that would be 15. They got 15, but they needed a quota of 26. So this would not pass. So basically, any individual player who just votes for it to pass would not be able to make this motion go through. So let's look at if I had player one and player two together. So for instance, if it was player one and player two that voted for the motion to pass, their weight would be the 15 votes that player one gets plus the 12 votes which player two gets. And so their weight in that motion would be 27 votes. And 27 votes, that's higher than our quota of needing 26. So in this case, that decision would pass. Notice if you have player one and player three instead decide that they're going to vote yes. In this case, though, I would have 15 and 10, 15 votes for player one, plus 10 votes from player three. This is 25 votes. This does not meet our quota of 26, and so this would not pass. So that tells me that, well, then player one with any of the other voters, just player 4 or just player 5 could not pass that motion. What if we have more than 2 players and player 1 is in there? So we got player 1, well, we know player 1, player 2. So basically player 1, player 2, and player 3, that would pass. If player 1 and player 2 is just needed. We'd have a weight of 15 plus 10 plus 10, which is 35. Okay, so kind of falling in that order. Well, let's see. Is there?
Wouldn't it be 15 plus 12 plus 10?
Yeah, you're right. 15 plus 12 plus 10. Player 2 has 10 votes. And that gives us 2737. So I'm curious, is there any way, do they need player 5 in any of these situations to make this a winning coalition? And so notice that 15 and 3, that's not going to work. None of these players and just player 5 would work. Player 5's not going to have it. And so just 2 people, that's never going to work with player 5. If we start looking with 3 people, so 15, 25, I know 15 and 12, they don't even need player 5. But if I do 15 and 10, that is 18. If I add in player 5 here, I want to see would that push them over the edge. Well, 15 plus 10 is 25, not enough. But if player 5 comes in, that would push them to 28 votes. And so it's possible that player 5 could be that one to pass a decision. And so
how many votes again is it that they need to pass?
26. So summing up the weight of each player who votes, to pass it, it has to be 26 or higher. And so notice if it was just player 1 and player 3, that number of votes wouldn't pass that motion because that's just 25. But if player 5 came in, they're possible to push it over the edge to make it pass. And so since player 5 here has some say in making some decisions pass, they're not considered a dummy variable. So example, if you look at player 1 and player 3, the motion won't pass. But if player 5 jumps in, they can make it a winning, make the decision to pass. Because their vote matters in that, then they're not a dummy. So therefore, they're not a dummy. Okay. So that might change though if the quota was larger. So like the second example we got where the quota was larger. What was the quota? I forgot. It was 34. So let's say that quota was 34, same weights of the each player. Let me just rewrite it. So what if the quota was 34? Are there any dummies? Okay, so if anyone's going to be a dummy, at least the last person would be a dummy, and then we can go through. And so let me just write down this notation. So we're looking at quota of 34. Our first player had 15 weight, second was 12, 10, 10, and 3. So again, nobody can pass this by themselves. If so, they actually are called a dictator. Let's look at this. So actually, and that they also have to be one of the people that can pass it. So let's look at this. So 15 and 12, that's not going to work because that gives me 27 votes and I need 34. If I do 15 plus 12 plus 10, that's 37 votes, that passes it. Here, 27 plus my 3, that's not going to help. This voter wouldn't help with three people voting. What if I did 15 plus 10 plus 10, that's 35, they pass it. They don't need this voter so far. So let's see, without player 1, what can happen? So let's say if I had player 2, player 3, and player 4 going, that's 12 plus 10 is 22. 22 plus 10 is 32. They don't pass right here, but if player 5 jumps in, they can push them over to meet their quota. So notice, so I'm just giving you one example where if you have player 2, player 3, and player 4 vote, their weight is 12 plus 10 plus 10. This is 32. So they don't win. Not enough. But then if we add that last player in there, they will tip us over the edge. But add in player 5, and then it's a winning coalition. And so since player 5 then has some say in some sort of coalition of votes, then they're not a dummy. And if the person with the least amount of weight of voting is not a dummy, then nobody else who has higher weight could be a dummy. So let's pull up another example. Again, I'm just going to first read through it and then we'll start writing down what we need to. I'm going to pull number 4 from the same section, still page 60, if you want to refer to the textbook and you have that online. So consider the weighted voting system where we have Q is our quota, and then the weights are 10, 6, 5, 4, and 2 respectively. So per A, what is the smallest value that the quota Q can take? So consider the following voting system. We have Q and then the following weights. So we have 10, comma 6, comma 5, comma 2. So what is the smallest value? That the quota Q can take? So any ideas? Okay, first of all, is it plausible to have a quota of a negative number of votes? All right, so no. So can't have a negative number of votes. Would it make sense if our quota was 0?
No.
No, right? I mean, that just doesn't make sense. Nobody votes, it passes. What about 1? Could we have just 1 vote or a weight of 1 for a quota?
No.
Why not?
I believe it would have to be at least majority. Yeah.
Okay. Everybody, let me just, if you want to go to the participation and just chime in there. So yes, you think 1 could be a quota, or no, you don't think 1 can be a quota? Thank you, Tyson, for being brave and answering the question.
Anytime. I might have been wrong, but
No, I'd rather you to be wrong and, you know, think about it and you had a reasoning why you thought that 1 was wrong. Okay, so 7 out of the 24 of you have voted no. No one has voted yes. Less than 1/3 of you have voted. Okay, we just made it up to 1/3. That's less than 50% of you have made a decision. So actually, as long as our quota is bigger than 0, I believe that that is a minimum. Because if our quota was 1, then basically what that's saying is that we need just at least one of the members, players, to vote, and then the motion would pass. It doesn't mean that that's a good quota, but it is a possible quota. So basically they would be saying in that case that what I just wrote, what is the smallest value of the quota you can make? I don't know why I put a 2 there. And now my thing is not working. Okay. That's why I kind of got stuck there. So basically, our quota, the smallest value, actually can be Q. So it's not the best, but it's possible. So technically, 2 could also be, but it's not the smallest. That could be a quota, and the same kind of reasoning there, that just if one person votes yes, then the motion passes. If we go up to 3, though, then poor little player 4 in this case couldn't by themselves pass a motion. Okay, so part B says, what is the largest value that a quota can take? In this situation, what is the largest value the quota can take? So think about it. What do you think the largest value would be and why? This might be. Okay, so I'm getting 23. And that's great, Stacia. So you said it's the max amount of voters. So basically, with all the number of votes possible, you would sum up all the weights, and then it can't be more than that, because if it was more than the weight of everybody, then even if everybody voted to pass or make that decision, it still wouldn't pass, which doesn't make sense either. So we would look at finding the total number of votes. So player 1 had 10, plus player 2 had 6, plus player 5. I'm sorry, player 3 has 5, plus player 4 has 2. So the possible number of votes is 10 plus 6 is 16, plus 5 is 21, plus 2 is 23. So the largest value that the quota can take is 23. The max of Q is 23. So jump into C. What is the value of the quota if at least 2/3 of the votes are required to pass the motion? So what is Q if at least 2/3 of the votes are needed to pass the motion? Well, we did part of the work already. We know the max. We know that Q here is 23. And so we need 2/3 of B. Sorry, that's not what I wanted to circle. I wanted B 23. Okay, so things are like slowing down. Doesn't want to work. So I'm going to look at 2/3. There we go. 23. It's just a delay effect. And so multiplying 2/3 times 23, 3 doesn't go into 21. So I'm just going to multiply straight across. 2 times 23 is 46. 46 divided by 3. I can only do this because this is a single digit I'm dividing by. So 3 goes into 4 is once. I have a remainder of 1. 3 goes into 16 5 times with a remainder of 1. So this is 15 1/3. Okay, so 15 votes is not enough. You're not going to get a 1/3 of a vote. And so Q would have to be at least 16. So part D. What is the value of the quota if more than 2/3 of the votes required to pass? I think that's the same answer as above. So what is Q if more than? Two-thirds is needed to pass. Well, if this had been a whole number here when I had divided and I maybe got 15, well, 15 would not have worked because that's not more than 2/3. But if I look at the number greater, next integer greater than 15 1/3, that's 16. So 16 also works. So Q could still be 16 or more, and then it would pass. Okay, so another terminology are players that have veto power. Okay, so if a player is needed in order to pass a motion, they are considered to have veto power. So if a player is needed to pass a motion, then they are said to have veto power. So knowing that now, let's go to the next example, which states you have the following voting where 7 is your quota. Player 1 has a weight of 4. Player 2 has a weight of 3. Player 3 has a weight of 3. And player 2, not player 2. Player 4 has a weight of 2. So in this example, we want to find, do any of these players, if any, have veto powers? This is part A. Any player. Well, basically, if we look at this, okay, player 4 is not, usually the person with the veto power, you're going to first look at the person with the largest amount of power. If they don't have veto power, that means nobody else is going to have veto power. And so we want to see, is it possible for the players to win without player 1, the one with the most power? And so if I look at the weight of player 2 plus the weight of player 3 plus the weight of player 4, I want to see, is that bigger than my quota? Well, 3 plus 3 plus 2, this is equal to 8, which is greater than Q. And since that makes that, they can actually make it so that they can win this without player 1. No one in this case has veto power. Player 1 doesn't have veto power, then no one else is going to have veto power. So let's look at B. So B in this case, we have that the quota now is 10. Player 1 has 4. Player 2 has a weight of 3. Player 3 has a weight of 3, and player 4 has a weight of 2. So again, I want to see, can we get this motion passed if we leave out the person with the highest number of votes? And so if I look at weight of 2 plus the weight of player 3 plus the weight of player 4, if this is bigger than my quota, I know that the player 1 doesn't have veto power. And so 3 plus 3 is 6 plus 2 is 8. And so the only way that this motion can pass is if player 1 comes in and tips the vote. Everybody else says, yeah, I want it to work, but they come in and they tip the vote. There's no other combination in here that we could work without player 1. So since player 1 is needed for the vote to pass, player 1 has veto power. Let's see though, because it's possible that more than one person has veto power. Let's say, let's see if player 2, does player 2 have veto power? And if they do, then also player 3 is gonna have veto power because they also has the same weight as player 2. So does player 2 or player 3 have veto power? So I want to go in here and I want to see, do they need either player 2 or player 3? If everybody else voted and one of those people didn't, could they pass the motion? And so let's look at it. So for player 2, which again is the same thing as player 3, let's look at weight of 1, player 1, plus the weight of player 3, plus the weight of player 4. Well, player 1, they had 4. Plus player 3, they have 3, plus player 4, which has a weight of 2. So 4 plus 3 is 7, plus 2 is 9. And so actually, player 2 and player 3 would have veto power because without them going in and pitching in their vote, they're not going to win. Okay, so player 2 and 3 have veto power. Okay, let's look at player 4. So does player 4 have veto power? Those things are jumping. So they would have some veto power if everybody voted except for them. And so 4 plus 3 plus 3. So weight of 1 plus weight of 2 plus weight of 3. We had 4 plus 3 plus 3. This is equal to 10, which meets the quota. So this meets the quota without player 4. So player 4 does not have veto power. Okay, so we kind of looked at most of the terminology that we're going to be using in this chapter. On Wednesday, we are going to look at different weighting systems. And so looking at, is that weight of the different voters, is that a fair way to distribute things? And we'll be looking at what's called the Bonsoff power and the Shipley, I believe, power index. But you gotta wait till Thursday, or no, Wednesday to see that.